Hey grade 10s, Mrs. Rivait here again. Today we are going to be looking at light and the electromagnetic spectrum. So we're going to look at the energy in light and how it is broken up into a spectrum. So before we talk about light itself, I just want to talk to you a little bit about waves. The reason is because light actually travels as a wave. So you need to kind of understand what a wave is. So a wave is a disturbance that will transfer energy from one point to another, but it doesn't actually transfer any matter. So it's just actually energy moving. And a way that we are very familiar with waves is in water. And we can see how the waves, the water is rising up and down, rising and falling, and it's doing so because there's actually energy passing through the water. And that movement of energy is allowing the wave to do some kind of work. So just some terminology with waves. A wavelength is the distance between two crests. The crests are the tops of the waves and the troughs are the bottom. And a complete cycle is from one full wavelength. So a full crest and a full trough. So I just want to talk to you a little bit about the relationship between the frequency, so the number of waves, and the wavelength, the distance between the waves. So as the frequency increases, as the number of waves increases, the crests are actually closer together. So the more energy that a wave has, the closer those crests are together. So the frequency of the wave increases, there are more waves, but the wavelength is shorter. Whereas with a lower frequency, we have longer wavelengths. So the distance between the crests is longer. There are less waves, and so there's less energy. Okay, so light is actually a form of energy. The light that we see, visible light, is only a small portion of the energy that we get from light all around us all the time. So we are constantly surrounded by these invisible light-like waves. So they are all part of what we call electromagnetic radiation. And electromagnetic radiation travels as waves. So again, longer wavelengths means less energy and a lower frequency. Shorter wavelengths mean a higher frequency and higher energy. So here's just a snapshot of electromagnetic radiation in its full spectrum. So there is a very large range. So from very low energy radio waves all the way to very, very short high frequency, high energy gamma rays. And kind of in the middle there is visible light, so the light that we can actually see. So what I'm going to do now is just talk to you about those different waves, those different frequencies in the electromagnetic spectrum, and what they are and what they're used for. So the lowest energy, the longest wavelength and lowest frequency are the radio waves. So there are many uses for radio waves. They're used for obviously radio signals, but also television signals. They're used for our cell phones and satellite communication, and they're also used in MRIs, so magnetic resonance imaging. Microwaves are shorter wavelengths than radio waves, so they have a little bit higher frequency and carry a little more energy. And there are several uses. Obviously, we know that we use them in our microwaves to cook our food. The reason that they can warm up our food is because they actually cause the particles to move, and that creates heat. Microwaves are also used in radar, so measuring speed of automobiles, and also in monitoring aircraft when they are flying, so the aircraft control. So the next wavelength is infrared waves. So again, a little more energy. Waves are a little closer together. So we experience infrared as heat. So you may have seen heat lamps in restaurants and things like that to help keep food warm. But other uses for infrared radiation is special equipment that it actually senses heat, and it can, so motion sensors in burglar alarms, things like that. Also, there is a type of night vision goggles that detects heat and produces an image from heat. And those are called thermograms, those images that are produced by heat. Okay, so we've kind of skipped over visible light. We're going to talk about that in detail in a minute. So then the next wave after that, or the wavelength after that, is the ultraviolet ray. So this is higher energy, higher frequency than visible light and all of the others that we've talked about. Our main source on Earth of ultraviolet radiation is our sun, so it's stars. And ultraviolet radiation is more dangerous if we're exposed to it for an extended period of time, right? We know that when we stay out in the sun without sunscreen, that we can get sunburns, and so it can actually cause damage to our skin and our cells, and it can actually increase our risk of skin cancer. There are other uses for ultraviolet rays, though. Because they are so high energy, we can actually use it to disinfect drinking water by killing microorganisms in it. So it can disinfect, and it also can be used in DNA analysis. Okay, so then higher still on our electromagnetic spectrum is the X-ray. So now we're getting to a point where we're talking about very high energy radiation. And these are things that we would not want to be exposed to for an extended period of time. So X-rays can actually penetrate human tissue, but they cannot pass through dense tissue like bone. And so that's why they're very good for taking images of our dense tissue like our bones to help diagnose disease or injury. X-rays are also used in security scans, so they'll take X-rays of luggage at airports and things like that. Okay, so the last type of wavelength that we need to talk about in our spectrum are the gamma rays. So this is the highest energy radiation in our spectrum, extremely high. So we do not want ourselves exposed to these very much or at all. Again, extremely high energy radiation. It can be used for sterilizing medical equipment. You'll kill off any microorganisms very easily using these rays. They're also used in cancer treatment because you can kill off those rapidly dividing cells. And gamma rays are actually produced within our galaxy and in other galaxies by neutron stars and black holes. Okay, so back to talking about visible light. So the light is energy that travels in the form of a wave. So white light is all of the colors of the rainbow together. That's the light that we usually see, but it can actually be separated into the colors that make it up. And each color has a particular wavelength that it travels at, and it's slightly different. So white light actually separates out into the colors of the rainbow. If you've ever heard of Roy G. Biv, that is the acronym that's used for the colors of the rainbow. So you can remember the order that they go in, because it's actually a specific order when we're talking about light. So it's red, orange, yellow, green, blue, indigo, and violet. And these colors together produce our visible spectrum. And so red is actually the lowest energy, so the longest wavelength. And then it goes all the way to violet, which has the most energy, so the shortest wavelength. So like I said on the previous slide, that white light can be dispersed or separated out into all of the colors that make up the visible spectrum. And again, the difference between those colors of light is that each color has a different wavelength and a different frequency, so a different amount of energy that it's traveling at. And again, red is the lowest energy, and violet is the fastest or the most energy. Okay, so I hope that you learned a little bit about how light travels and how light is all around us, and I will see you next time. Thanks for listening.